past, I would say, thank you, for 9 years or so. And last year, my team went through a transformation to be able to combat and compete with the different ways of working that we have adopted since the advent of AI. And since then, evals have been a cornerstone of how we operate within the QA organization. So today I'm going to talk a little bit about crafting evals, and I'm going to talk a little bit about how we have done within Glassdoor slash Indeed, and what we are still working towards in order to have a more robust infrastructure that can support AI development. But before we get started, any specific questions that you all have that you all want answers for so that I can craft my conversation accordingly? All right, feel free to put it in the Zoom chat. And Tatiana, if there's a question, please let us
Yes,
know.
I'll
Let
watch
me
the
know what it is.
questions and any comments. I'll let you know.
Awesome. Thank you so much. All right, I'm going to share my screen. I have a handy deck created so that we can have a flow of this conversation, but I would like to say this. I want to make sure that this conversation is a bit more interactive. So if you don't understand something or if you need more information about anything, just let me know. I'll interrupt the talk and happy to go in on any tangent that you all need. All right. As mentioned, crafting evals has been something that my team and I have been working on for the past 12 months. So I want to give you a little bit more of a background on that before I get into the conversation. Um, so the first few months, our team, and including myself within the team, went into this research and discovery phase of understanding what are the tools that might be helpful, that what are the tools that are essentially out there that can do the job that we need, which is able to understand how our algorithms were performing, how our chat systems were performing, how LLM essentially was doing, and how we could get any sort of quality indicators or signals through them. We took about 3 to 5 months to go through the POC process for a bunch of tools that are out there. DeepEval, Datadog, Arise. There's so many that are out there that I don't even think I can recollect. And every single day, there's a new tool that has come up that is promising to do everything and more of what the other tools have done. So I think one of the things that I would like to call out as we get started is the trap of vendors or the trap of the tools that you have out there. One thing that we had to learn the hard way is how not to get into that trap and how to essentially first understand what kind of infrastructure do we want to build? What is our end goal? What are the signals that we are trying to put together? And then, based on that evaluation, getting into a more concerted effort of identifying which tools fit the bill. So, anyways, moving forward, we took a few months to get through the evaluation, and then finally we started putting the building blocks together to be able to craft our evals. And I would say that it's still a work in progress. We have had 2 iterations of massive products that were launched over the past 12 months, 2 to 3, I would say. And these evals that I'm going to talk about today have been extremely helpful. They've been one of the sources of directions and signals that the product, as well as the engineering teams, as well as actually the ML teams, have been using to be able to craft their models better. So what do I want out of this talk? I'd like to share what we know, what I know, what the team and I have been able to develop. Because as I've mentioned, some of these details we had to learn the hard way. So I'd like to pass that knowledge. And then I also would like to learn more from you. This is such a new space. We don't have all the answers. We are actually still developing infrastructure, processes, the rights, the do's and the don'ts of how to have good evals. I'd like to learn what all of you are doing within your organizations as well, and how we can learn from each other to be able to build better systems for quality. I'll pause here before getting into some details. Any questions? Anything that you'd like to learn more about from what I've said so far? Okay. All right. Let's keep moving forward. All right. Um, I think this is one of those generic slides that we use as a first step to be able to get into talking about evals. So I'm gonna do it a little bit of a justice and give a very high level scenario of what used to happen before evals were in place within some of the organizations that I have either worked with or talked to. Um, Without evals or without quality harnesses, we can have directional signals that can help us understand whether our product is doing well. For example, bugs. Bugs are a very good indicator. Whether you have production bugs or customer-related bugs that you get through various feedback channels, that can be used as a parameter to understand whether your model is doing well or not. But it's incomplete. Anybody who has experience in quality or in general software engineering, you all understand that these customer bugs that we essentially receive or production bugs that we identify, they just talk about one aspect or one dimension of the story. So when we see that the models are getting developed and maybe some numbers that you all are tracking are getting better, without having a proper quality harness in place, they just tell you a very unidimensional story. And unfortunately, that's the reason why it's without proper evals in place, it's difficult for you to understand whether the model that you have deployed in production, whether the system that you have built is giving you what you need, is meeting the business requirements, is meeting the strategic requirements that your business needs. So, how do we essentially do it? Um, we do it in a way that fits the bill that we are trying to, or fits the bill for us or the goals that we are trying to achieve. Two leaders that I follow very closely and kind of listen to their advice whenever they post anything on LinkedIn or any other forums are Hamel and Shreya. Both of these folks have done extensive analysis on evals. They also, I believe, have some really good courses. They have talks and a bunch of documents that are out there that can really help you understand how to put the entire pipeline together and give your teams the details that they need in order to be able to quantify quality in the right way. They essentially they have also put together, I believe, a bunch of flashcards that you can use in order to be able to kind of remember whenever you're trying to put together a new eval, what are the things that you should essentially be looking at as well. But the two things that I really like that they have called out so far is LLMs should feel like unit tests, or LLM eval should feel like unit tests. They should be lightweight. They should be built in a way that can tag alongside with code altogether. And then what Shreya essentially mentions is like whenever the data is drifting or your model essentially is drifting, it is invisible. Until and unless you have evals, you have no idea how far the drift essentially can be. And we kind of see this in action. We've seen this in action multiple times within our organization. And when have had a chat with other industry leaders, this is one of the things they talk about as well. So let's talk a little bit about some real data points or something that's much more tangible that I can use in order to kind of share with you more about what we have built within Indeed and Glassdoor. So as you know, Indeed and Glassdoor are focused on jobs, recommendation of jobs, helping you find the right job, helping you get your dream job. And that's our product essentially. So what we use in order to be able to generate some of this recommendation is your information. What we would like to understand is, as Tatiana, um, what kind of jobs are you looking for? I'm just going to take Tatiana's profile as an example. Tatiana lives in Seattle. She's looking for QA role. She's interested in quality in general. Her skill set is related to Java and Python and say Selenium and so on and so forth. And then this is in terms of her salary. These are her salary expectations, and this is what she has as a must-have. This is the data that we generally collect in order for us to be able to understand what you need. And then based on this data, we give you a recommendation. We say, hey, Tatiana, it looks like this job in Amazon as a quality engineer seems to be the right fit for you. And then we say the overall fit for this particular job is 0.82, because that's what our model tells us. And then the skill set based on what the job description skill set based on what you have in mind is 0.88. And the location match is an exact one. You want it in Seattle, you get it in Seattle. The salary is 50 because you wanted X amount, but you're getting X by 2. So on and so forth. Some of these numbers are spitted out by the model that we have, the product that we essentially have. And we say this is the right job recommendation for you. Now, our job, my job specifically, and my team's job is to be able to evaluate based on what information this model has given. Is this right? Is this actually what Tatiana wants? Is this a good match? How do we know the details about it? To solve this specific problem, we have put together a layered approach. And before I talk about some specific building blocks within the layer, I want to talk about how we approach this problem altogether. So actually, you know what? I'm going to talk about this one and then I'll come back to that particular piece because I think we have a good rhythm over here and I want to address some of the processes that we have built to put this together. So as I've mentioned, we have user profiles that we capture. And based on that user profile, Tatiana's profile as an example, we get a recommendation. The recommendation that we essentially get, we pass that to something called as an LLM as a judge. And this is one of the tools that you can apply, or one of the frameworks that you can essentially apply to be able to evaluate whether what your model is spitting out is something that is of good quality or not. And that's one of the things that we adopt within Indeed and Glassdoor. We heavily employ LLM as a judge as a framework to be able to understand whether our models are working as expected or not. So we pass it along to another LLM, and we create our own eval prompt that essentially says, all right, so this is Tatiana's information. This is where she wants to work. This is where she wants to work, Seattle. This is how her skill set currently looks like. Now tell me, is the recommendation that has been generated by Indeed system, is that a good match or not? And we create an entire eval prompt for it. This process of taking a recommendation or taking output from one LLM and passing it to another LLM is called as LLM as a judge analysis. And then based on the data that we essentially get back, we then structure it, we label it as either a good match, a bad match, a weak match, a partial match, and then we store that data. We do this again and again and again and again with various data sets, with various users to be able to understand how is this model performing. And then we set a baseline for it. And we essentially say, for this particular, for let's say V1 model, we see that folks like Tatiana who are in Seattle, who are looking for a QA role, the LLM actually is performing very well. I'll pause there. Any questions? Does that make sense? Or let me know if there is anything else that I can provide to um, support the data. Okay. All right. I'll add a little bit more layer to it, and then I'll go back to the previous slides and support my statements. Oh, looks like we have a question.
Hey, thanks. This is Nehal. So I just wanted to quickly understand
Yeah.
that is that something is like you have already LLM judge? Is it like do you have the test orchestration created already, or this is, or I'm not sure if you're gonna dig in deeper in that part yet. But I'm looking at more details. If you could poke into that area, where
Yeah.
how are your tests lying, and what models are you using beneath?
Yes. I will talk a little bit more about it, but since you have asked this question, why don't we just address it directly? Let me try and see if I can go back very quickly. Okay. Yes. Your question is right, Snehal. Like, how have we created this LLM as a judge? What are the tests that are lying over there, and how do we make sure that we are getting the signals that we need, right? So we do this in four parts. The first part is we collect a golden data set, and it can be of various forms. So right now, I just gave Tatiana's profile as an example. For one of the products that we essentially launched a few months back, we created, I believe, 8 datasets with 200 users each. So that's what we call it as golden datasets. But think about this as just use cases or test cases. In our previous deterministic testing, where we didn't have like this behavioral, non-deterministic behavior or probable behavior, we used to just put together test cases. So the golden data sets just represent those test cases. What kind of users can you have? Users who are happy path, like Tatiana's data, which is straightforward, or people who are trying to pivot their jobs, or people who want senior roles, or people who are students, and so on and so forth. So that's basically our step one. We collect data to be able to analyze the model in multiple directions. Second one is we build a harness, which is LLM as a judge. And some of the tooling that I had referred to in the past, which is Arise or Datadog, or there are a bunch of open source evals as well that are available out there, or even deep eval. These tools essentially give you the framework that is required to be able to work with LLM as a judge. You still need to have basically a key, either an OpenAI key or a Claude key that can do the needful for you. But they will provide you with the testing framework so that you can pass in your input, you can create an eval prompt, and then you can generate an output based on that. Now, one of the recommendations that I would have when you're creating your LLM as a judge, or when you're putting together the framework for your LLM as a judge, is not to have the same model as your product's model. So the ML team, they might be using, I'm just going to take an example, Claude's Sonnet, some 4.5 version or something. Try and opt for OpenAI version. So one of 4.0, 4.0 mini. Generally, 4.0 mini is the preferred one when it comes to evals because it's lightweight, it's cost effective, it isn't extremely expensive, or because it can do calculations very quickly. One caveat with that is if you have massive data, like let's say you have, in our case, we had 200 users. When we started going to 300 or 400 users within our golden data set, we started getting some poor results. That's when we had to switch to 4.0. So you can use an OpenAI key or a Claude key to be able to integrate your tooling essentially with a model that's out there, build your eval prompts, which is basically system prompts for evals, and then you can run based on it. You, everything else in terms of your scripting is basically what you have been doing already, which is you get your output and then you go ahead and flatten it out, do whatever you essentially need to do in order to be able to kind of make sense of the data that has come back. And I'll try and see if I can share one of the examples with you so that you can see what I'm talking about. But Snehal, does that answer your question?
It does. It actually makes me ask you another question.
Please.
Maybe I'll chat. I'll throw it in chat. Um, I don't want to disrupt your flow.
No, go ahead. Go ahead. If you want to ask a question, feel free to do that.
Okay, so thanks for that explanation. Now I'm curious here because this is the data there, right? I mean, I would imagine this is a sample data,
Yes.
right? So when you're testing, of course, you know what's actual result is and when is expected result, and of course you're using two different models so that you kind of not corrupt the result, right? But then you're using these models. Where does your data integrity lies, and how do you make sure that in real tests, like let's say on your QA environment or in your even, I don't know, less than prod, how are you making sure that the data is not corrupted, as in, like, because this there could be some details of PI respective, right? Especially in your industry.
Did you say PII?
Yeah. Yeah.
Okay. Uh, let's decide. It looks like there are a bunch of questions in that question. So I'll try and see if I can decipher one after the other. The first one is like data integrity. How do you make sure? I think basically what you're trying to ask is how are you locking in the data to make sure that the results don't deviate from one day to the other? How do you create those golden sets so that there is no disruption and there are no integrity issues within the data? So I believe that might be your first question.
Yeah,
Okay.
yeah.
Okay. So think about this as a simple example as in the previous world before AI was ever invented, um, we still had this problem. Data integrity or having a better handle on the data that you're creating was always something that QA engineers were responsible for and had to deal with. That struggle kind of continues even now. The way we handle it within our organization is we collect the data, we create our own data, we put it in, the way that we essentially do it is we ensure that there is no other interferences that are happening within that golden set because we use various means of communication to put it under lock and key. And the key is only within the QA engineering team's um, purview. So we create the data, and most of these analysis we do it either on non-prod environment where we don't have those PII restrictions because it's something that we create and it's non-prod. Outer world does not have access to it. So we create this data. We never use real user data. So Tatiana was just an example, but if Tatiana went and looked up Indeed and was, doing any kind of interaction with Indeed, we would never use our data to be able to do any evaluations at all. In fact, um, if you are doing evaluations on real users or real user data, that will provide unrealistic results altogether because we have no control over them at all. So it's a very, any sort of evaluations that we do, similar to any UXR studies that your team might have been performing or any like UATs that your team essentially performs. It's very constrained. It's in a way that you have full control over the data set that you create. So those 200 users, nobody else is using it except for our team. And except for evals, nothing else is intervening in the process of either creating or maintaining that data. So that's number one. Second thing is, as I've mentioned, we try to do most of our testing within PIR, within stage itself or lower environments itself. So we don't get into this PII issues. But there are times when we have to do it on production. And even then, we do it with the data that we have created. As I've mentioned, we always create the data that we want to run evals against. We do whitelist those users to be able to make sure that we get access to traces or we get access to the data that is required in order to do this evaluation. Um, it is a process that requires you to work with the platform and the DevOps teams and the security team as well to kind of ensure you're getting access to the PII data. But as long as the teams know that this is what you're working on, in my experience, they have been extremely flexible in fetching you that information so that they can see the analysis that these evals do.
Yeah, that makes sense. I mean, there will be a lot of data scrubbing that I would imagine, and then coming with those sets. Yeah, thanks.
Sure. At some point of time in this conversation, I'm also going to talk about online evals, and that might help you understand things. That might be able to connect things a little better on what we do with real user data, not just the data that we essentially create by ourselves. But it was a very good question, Snehal, because everything that I'm talking about right now, it's called as offline evaluations, which is we create our own data, we manage everything, and we generate reports to be able to identify how the model is doing. Something called as online evaluation, which I'll talk about in a minute.
Awesome. Thanks.
All right. Any other questions? All right. We're going to get into the meat of the matter over here. The third thing that's extremely important. So we've talked about golden data sets. We've talked about LLM as a judge and how to build that harness. But the third thing that's extremely important in my perspective, because these two things, this we have a handle on. This is something that you can also, there are a bunch of tools that are out there. If you give it enough money, they can kind of build the entire harness and give it to you. You don't have to even create scripts. But what nothing out there can help you with is building your own multidimensional metrics. And what I mean by that is go back to this example that we were talking about. If you all have been working with evals in any form or fashion, or just working with AI in any form or fashion, you might be hearing a lot of buzzwords that are out there, like bias and hallucination and recall and context evaluation, or negative output, or there are so many things that are out there, I don't even remember. But all of these things are generic um, metrics that are out there. What your what your eval should be anchored on is your use case. What are you trying to solve? What is your product trying to solve? With Indeed and Glassdoor, one of the use cases that we have is we want to give you job recommendations. So we want to make sure that the job recommendation that is given to you matches your expectations, your needs, and what you want. We don't want to give you just any job out there. We want to make sure that we understand who you are as a person, what you're looking for, what your interests and preferences are, and match it accordingly. So, yes, we want to make sure that our LLM is not hallucinating. Yes, we want to make sure that our LLM is not biased. Yes, we want to make sure that our LLM does not have any recall issues. But at the same point of time, I want to make sure my evals give me a signal on how well the user's profile is matched to the job recommendation, i.e., if Tatiana's location is Seattle, is the job actually in Seattle? Is the salary matching Tatiana's expectations? If not, what is the delta? What is the difference? Is it over it? Is it under it? In terms of the role that has been recommended, is that something that Tatiana essentially is looking for, or in the vicinity of what she's looking for, or is it completely different? So we come up with custom metrics, and that's the recommendation that I have for all of you as well. Come up with custom metrics to be able to identify what your product essentially needs to be doing and define quality based on that. So if you're working for Airbnb, don't just have hallucination and bias as metrics. Have different vectors like the user wants a house in, I don't know, Seattle. Is the recommendations for properties that are showing up, are they all in Seattle? Are they in Seattle metropolitan area? How far away from Seattle are they? Oh, they wanted a massive house with 6 bedrooms. Are we showing 6, 7, 8? And if we are showing 6, 7, and 8, which order are we showing them in? Is it first 8 and then 6 and then 7? That matters as well. Because in this day and age, grabbing attention of audience and users is extremely difficult. So if you don't rank it properly, you first show a house with 8 bedrooms, the user would be like, well, I wanted 6. This is a lot more. And it's out of my price range. Why am I seeing this? And somewhere down in the list, your 6 bedroom house would be buried, which essentially means it won't be clicked on. It won't be something that is sold or rented for. So it's extremely important for you to have metrics that essentially define how your quality of your product is and what it is trying to do. So in my experience, what we have done as part of Indeed and Glassdoor's matches recommendations is we have created multiple dimensions to understand if location is matching. So we call this as match labels. If location is matching, if job title is matching, if salary is matching, if profile as a whole is matching, if the scores are matching, so on and so forth. So we have come up with these custom metrics that can provide us the direction to be able to understand against each and every one of those dimensions, the recommended job, how does it essentially look like? Before I go to the last point, any questions? Okay. Last one is pretty obvious. Once you build all of these things, you need to put it in a pipeline so that it can run automatically. I will say there's a lot of merit to human in the loop. So even if we have a pipeline that is running, right now we have a pipeline that's scheduled and it's running on a daily basis that gives me information, that gives engineers information about how our evals are looking like. We 100% enforce a human in the loop analysis. And without human in the loop analysis, we are not able to come up with those overarching guidelines that we essentially need to provide the ML team or the engineering team to say, hey, the model has drifted, but it has drifted only for this particular cohort of people or this particular dimension. We could use, another LLM to be able to generate those results, but as you all understand by now, LLMs do hallucinate, LLMs do drift. So fully relying on an LLM, even if it's as a judge, is not something that we would recommend. We want what these LLM and judge as judge will give us is analysis against a very large data set, which is going to be tedious for one person or even a group of people to be able to do. So it can get us quantity and it can get us quality directions, but at the same point of time, we want human in the loop process to be able to come to look at outliers or any patterns that LLM might miss. All right. So I want to talk one more thing about how we have created this evals process for the job matching system that we have. Um, I've talked to you a few minutes before. I talked to you about these four areas that we wanted to kind of piece together, build the blocks together to be able to come up with the holistic system. One of the things that we found extremely interesting is to be able to find confusing inputs, or what I call as is diverse inputs. So Tatiana's example that I had taken was just about a user who was interested in quality, had experience in quality, and was looking for quality jobs. But there's so many things that are out there, right? Like there are, as a person, you might want to change careers. As a person, you might have government clearance and are looking for jobs only with government clearance. As a user, you might want to be looking to do only remote roles or only hybrid roles or only in-person roles. Or you might be looking for very senior level positions like VP and CTO and CEO, where we know we don't have for every company, there's only one CEO. There should probably there's in some instances there might be more than one, but most instances there's just one CEO. So there is a lack of job liquidity that's out there. Similarly, you might be someone with less data within your profile. So if one of the users decides to not input location or not input salary, that is sparse data that we then have to deal with. So we started like putting all of these users in cohorts to be able to build what we called as different groups of golden sets. Users with seniority titles, users who are students, users who have sparse data. And then we started running these as experiments to be able to give more directional signals to the ML team. And that's how we were able to identify more interesting um, uh, patterns. And those were like, our model actually is doing really well with seniority titles. Our model is actually doing even better with students. Our model is doing even better with metropolitan locations. And for the rest, our model is doing really good, but fairly, in the moderate zone. And so just again, that was a bad example, but then I just wanted to make sure that you kind of understood that building evals is one part of the process, but building the input that essentially can help you get signals is a very big part of how quality assessments are done. And that's also something that as a team you should be looking at. And that's part of in general, that's part of our QA processes. But test cases building and thinking like a quality engineer is a critical part of this entire role. Okay. Before we move further, Tatiana, how much time do we have? Just want to make sure.
We still have 20 minutes.
Okay,
And if
perfect.
you're taking questions, along the way, then yeah, that's fine. Or you can leave time at the end for the question.
Yeah. Why don't I'm just going to very quickly pause because we've gone through a bunch of things here. Any questions at all before I talk about a few more things? Okay. And this is going back to your question, Snehal. How do we make sure that the data that we are essentially passing in is good enough? What are the things that you're essentially looking for, and what is online versus offline eval? Let me first address a couple of things over here, and then I'll talk about online eval. Everything that you have done, so everything I have talked about so far, and everything that you do within your lower environments, it is most likely an offline data set. And what it essentially means is you keep building the data that you need, then you pass it to LLM as a judge, then it essentially gives a report. You take a look at that report, and then based on the analysis from that report, you tweak your model. You tweak the system prompt of the model in a way that aligns with the direction that you want it to. So, as mentioned a few minutes back, you want to check for prompt changes. You want to check for, whenever there is a change in your ML model, whether it's for prompt or whether it's a model upgrade or whether it is, some formulas or weightings are changing. You want to make sure that you are running these offline evals to be able to get signals on how well the new change is working. If the prompt has changed, how well is it working? If the model has upgraded, how well is it working? And you always need a baseline. So the first run that you essentially have, that will have no baseline. That will be your primary run. That's what you're going to move forward with. But every incremental run that you have after that becomes something that you compare with your previous run so that you can see the delta. So going back to the example that we were talking about, if you are looking for a house within Airbnb's portal, and you have looked for a house in Seattle, there's a underneath the hood there is a location eval that essentially is running, and it gives you the houses, the recommendations of the houses that you essentially get are all in Seattle. The eval essentially would work in a way that it will tell the team members that for the 5 recommendations that I've shown to the user, the first one was in Seattle, the second was in suburbs of Seattle, the third one was 15 miles away from Seattle. It's a bad example, but then I'm trying to kind of put the scenario together. And the fourth recommendation was 80 miles away from Seattle. So in this particular scenario, what the team will essentially go back and do is they will take this data and say, all right, it seems like our location eval is telling us, it's giving us a signal that it's not, the recommendations are not all working very well. Let's go ahead and build newer model to be able to address this. So when a newer model is built and you rerun the evals, you want to come back and you want to measure it against the previous evals. You want to see the delta. How much for the first recommendation that was generated, how much did the location eval score change? Was it better? Was it worse? Did it stay the same? What essentially happened over there? So when you compare this A versus B, the delta that you get, that becomes a signal for the model to essentially for you to be able to understand how the model has drifted, whether it has drifted positively or negatively. And if so, that can be shared to the ML team to say, actually, this is looking much better. Sometimes what happens is the signals that you get are all mixed. You see that the location eval is looking much better, but then say the eval that is looking for salaries in our case, that is not working very well. At that point of time, your team and you would have to make a choice. Do we move forward with this model or do we stay with the previous model itself? Each and every time you're making these decisions to be able to understand whether you should be A/B testing, whether you should be moving forward with launching this to production for real users, or if this is something that you should keep back, should hold back, you should tweak more before launching it into production. So that's basically the way this entire process works. You get a baseline, you then keep comparing it again and again and again on a daily basis to be able to get the signals, to be able to understand how the model is working on a day-to-day basis, on a week-to-week basis, if that's your cadence for production launch. And then you make decisions based on the results of these evals, and then you move forward with your next steps within the strategy. As mentioned, you want to also do regression checks apart from the checks that I've talked about, which is when anytime there is a change. You also want to do regression checks in general, just like the way we run regression execution for our deterministic features. You also want for any release that you're having with the model. Let's say even You don't have any prompt changes, you don't have any model changes, you don't have any formula changes. You just have a very simple plain change somewhere in the model that shouldn't be causing a lot of changes. You still run regressions. You want to make sure that evals, there is no change in evals, there is no change in higher level signals before you push anything to production. And that's why ideally you should put all of these things in CI/CD so that it's automated and you get a headline through your eval system that says the stats stayed the same for all of your metrics. There's been no change in hallucination, no change in other biases, no change in other metrics as well. All right. Let me talk a little bit about online evals now. So far, as I've mentioned, offline evals are all based on the data that you create. Offline evals, the data you have it under lock and key, you create golden sets, you don't let it deviate. Any changes to the data set essentially will affect the evals that you're running, so you don't want that. Online evals are a little different. And this is particularly true when when your team essentially is not looking at production behavior. And what I mean by that is if I, as a team member within the QA org, I am responsible for building out my test data to be able to give to evals. And if I don't understand how my external users their profiles have been, what their data is reflecting, whether within my ecosystem, are there users that are of a certain demographic, of a certain type, um, of a certain category? If I don't have that information, my offline evals will not reflect any of it. So, for example, Airbnb, US might be the biggest market for Airbnb. I'm just making that assumption right now. If the evals for Airbnb is mixed for all countries that it supports, all, let's say, 100 countries that it supports, then evals are not doing a good job of representing the market share that Airbnb has within US, and it's not targeting the cohort of users that it should be looking mostly at. At that point of time, there's a disparity between what your offline evals are doing versus what your online evals are doing, and which is why you need a dual strategy. You shouldn't be just looking at one. Offline evals are good. You should continue working on them because they provide direction. But online evals truly give you what the feedback of the users are, what users are essentially experiencing. Again, based on the tooling that essentially houses your traces. You, again, as I said, you have Datadog, you have Arise, you have so many other tools out there. These tools also provide you with something called as online evals. And Snehal, your question was like, how do we make sure that PII data, scrub data is not is something that we don't interfere with? These evals, the online evals, do take care of it. And what I mean by that is if traces essentially are passed along to these online evals, they do all of the calculations themselves. You are actually not downloading any data. You're not doing anything. It's within, think about it as it's something that's within within the tool itself. It does all of that and it shares the values back to you. It says, hey, this is looking good. This is not looking good. Evals for hallucination are looking bad. Evals for location matches are not looking good, so on and so forth. Only difference is in offline evals, the script and everything that you're building it outside in Python, you're creating a GitLab repo, you're doing all of it in order to be able to process data. Conversely, when it comes to online, all you're doing is just you're building system prompts. You're building eval prompts and you're plugging it in the tool that these Datadog, Arise, and so on. Any tool that you're essentially using, you're plugging it in to be able to generate those evals. Now, there might be a question like, why are we not just focusing on online evals then? Because it'll give us all the information that we need. It's real user information. It's just that the risk is higher. Until and unless your model hits production, you'll be flying blind then. And that's not what teams or companies want to do. They want to make sure that they are able to, before they push anything into production, they are able to gauge the changes that essentially a new model will cause, be able to articulate the change, be able to articulate the impact of the change, the quality impact of the change before they push anything into production. Even if it's an A/B test, you want to have some signals before you go to production. Even if it's a tiny percentage of the traffic that you're trying to tap, you still want to make sure offline evals are used to be able to make that assessment. All right. I'll pause there because I think I'm wrapping up with just a few more slides. Any questions? Anything that seemed extremely interesting or not interesting at all?
Hi, I had a question in chat. I'm actually here, so I'm not able to, you may not be able to hear me, but I'm not sure if that's something that you can share with little light.
Let me take a look. Not sure if it's in scope of this talk, but interested in getting closer look on how does pipelines look? How does these tests run in CI/CD? What proximity does it have with other test artifacts running in the pipeline? I'm doing something similar in my project, so curious what pipeline challenges you faced in productionizing this. It's a good question. I'll try to see if at all I can answer it succinctly. It wasn't something that I was hoping to touch, but I'm happy to share the information at least. So how does these tests run in CI/CD? They're similar to any other tests that you have in at Glassdoor slash Indeed. What we have done is we've put them in GitLab pipelines, but you can do the same in Jenkins. We have done that before, or you can do it in any CI/CD tool that you essentially use. All you essentially have to do is if you're using GitLab, you go to your YAML file, you add the configurations over there to be able to point to the test that you essentially want to run. And then you just create a pipeline and you schedule it using the editor. And that's pretty much it. It's pretty straightforward. The challenges that we have experienced, which are a few, the challenges that we have experienced to be able to productionalize this is so the way our system essentially works is we fetch the information from certain endpoints to be able to understand how the recommendations look like. And then we pass it along to evals to say, hey, this is the output. Now process these evals and or process this data, generate evals, and then help us understand how that looks like. The data that you send to process can be massive because it has the lay of the land. In fact, if you don't send the system prompt that the model is using, your product model essentially is using, the LLM as a judge cannot do half of its job. It needs to understand what the expectation was with the system prompt that your product had put out to be able to give an assessment on it. Apart from the system prompt, it needs to have information about the state of the, say, user or whatever essentially you are trying to evaluate. You need to understand the state of it. So in our case, we need to provide user's profile. So again, going back to Tatiana's example, we need to provide Tatiana's information, no PII information, but we still need to provide information about what was Tatiana looking for? Was she looking for a job? Was she looking for salary? What was she looking for? So you need to pass that along. And then you finally need to pass along your own eval. You need the LLM to do some analysis, and that is all in an eval as well. So a lot of these things is just prompt engineering to be able to generate that final output. So what we have experienced as part of this GitLab pipeline configuration is sometimes passing this large amount of inputs does make it extremely slow, does make it sometimes flaky. But I would say the probability of that happening is relatively low. It isn't something that has caused us a lot of pain as long as you can follow the best practices of CI/CD to be able to do so, which means don't put a lot of heavy information within it. Like don't process. So for the 200 users that we try to process, we kind of chunk it out to 50 users for each pipeline, and then we send that information. If you did all the 200 users together, it would take a lot of time. The other thing is you want to make sure, again, the CI/CD essentially means whenever your deployment happens of your model, there are triggers put in place to be able to kick off your evals as well. We are not at a point where we are having hard gates, which essentially means if the evals say the model has drifted, don't let anything merge yet. We do still have, as I've mentioned, human in the loop in the process, but eventually the goal is to make it fully automated, fully seamless. So I think the headline that I want you to leave with is, I think the CI/CD part was the least friction part of this entire process. The actual generation of metrics, the LLM as a guard harness, and then also putting the golden sets together were the heavy lifting. Once you take care of all of these three things, CI/CD is fairly as simple as any other pipeline that you perhaps might put together for test execution. Thank you. That was a good question. Any other questions? All right. Let's try to see if we can wrap this up. Give me 1 second. All right. It's also important to understand, this is where we get into the noise part. We've talked a little bit about it in the past. Having generic evals like hallucination and bias, although needed at times, are not sufficient. You need a little bit more custom. What you also want to make sure is, as I've mentioned, have baselines in place and have additional processes in place when you're at least starting off, to make sure that there are no mirages in play here. What I mean by that is, we actually, initially when we started putting this entire process together, each step of the way, we had someone go in and take a look whether we had the data that was set up correctly or not, whether the LLM was doing the job that it wanted to do or not, whether the output that was generated from the LLM, was it giving the right signals or not. And then finally, like even within traces that we essentially finalize at the very end of the day, is that getting all the information that it needs to or not? So having human in the loop every step of the way, initially at least, is extremely helpful. Once you get confidence, a little bit of confidence in your model, then you can start relying solely on just changing the eval prompt, and then that can kind of give you the results that you need. But as in any system, as for any code, just because you have created one eval prompt doesn't mean that it requires no tweaking. Whenever there is a business requirement change that happens on your products end, it's important for you to be able to reflect it in one way or the other within your eval prompt as well. Again, going back to Airbnb, if the requirement goes to having open prompt in their filtering search bar, they have this filter bar where you can go ahead and put in like location and so on and so forth. So let's say if that became an open prompt, that would completely change your eval, because now, apart from just taking structured data, you will be able to take any sort of data. I could go in and I could talk, I could put my request in 500 words. Previously, it just had structured data where it was taking location and the distance and maybe a few other fields. So any changes that are happening within a product would essentially mean that, or business requirements would essentially mean that you would have to make sure that there is changes that are happening within eval prompt as well. And then the other thing that I would call out is, and this is something that I wanted to put over here, gains persist for 2+ weeks in production with consistent volume, which means you don't want to do just one analysis and call it done. You want to make sure that you are continuously taking a look against different data sets, how your model is performing. And once you get similar results, or if you get at least a result that is in a particular direction, you can then say with confidence, all right, this model is doing better. Typically, what I've seen industries essentially do is they have a first run for baseline setting, as I've mentioned, the second run to get some directional data, and the third run to essentially say, all right, this is now solidifying the assumption that we had made as part of the first and the second run. So there are 3 runs that essentially need to happen, again, as I've mentioned initially, but depending on your model, it could need more than that to be able to have confidence in how your model is performing. It also heavily depends on the data that you have put together and the confidence that you have in data. So please take that the grain of salt. And then finally, for anyone who's interested in doing evals more, here's what I think might be might be something that is interesting for all of you. If you have anything like a chat agent within your teams that you have recently launched, or any sort of an output that you can get your hands on from an LLM pipeline or a model, just take it and do human in the loop analysis. Come up with some labels. Depending on the industry that you are in, you can have labels like something that is like strong matching, like yes, it matches the expectation that I have, or no match at all. It's not matching what my criteria is, or weak match or partial match, and do that as a human. Don't do it as an LLM as a judge, but do it as a human, and try and see if you can label that and see how you would vision your LLM as a judge to perform. That can essentially give you an assessment on how to build a system that works for your use case. How would you want the output to be classified, to be labeled in order for you to get the direction? Once you have that in place, then you can start looking at some of the tools that are essentially out there, like Datadog, Rise, and so on and so forth, to be able to use this as LLM as a judge, and then run that through it and do analysis based on your human labeling and the LLM labeling. That can give you a holistic idea of how you want to build your system. But that's pretty much it. That's what I had prepared for today, and what I wanted to share. I'm going to stop sharing. Any questions? Anything that I can add more details to?
Hey, a quick question. Can you share the timeline, as in from the start to this point? How much time did it take to build the LLM pipeline?
Well, I would say it depends. Like, we had to put together something fairly quickly because we had a product that was coming up and we needed to launch it in a short time frame, I would say. So we did start our initial assessments, as I've mentioned, last year. It was actually, if I remember it correctly, February of last year when we started dabbling around with tools that were out there to be able to understand what we could build. In order for us to have something functional, it took us, I would say, 3 months, 4 months. It took us 4 months to put something functional together. But I would call out that was then. It was still something that there was a bunch of information out there, but we had to synthesize it to be able to do this. If you start now, if your teams plan to start on these end-to-end pipeline now, you can productionalize all of this information, all of this pipelines and data within, I would say, a month, under a month. It shouldn't take a long time to put all of these data together. What you should be essentially what you should focus on, as I've mentioned, is what is your product? What are you trying to drive? What kind of structure and infrastructure do you essentially want to put together to be able to support the products that you have within the company? Once you have that assessment, then take a look at the tools. Do you have budget for a paid tool? Are you looking for an open source tool? That should happen fairly quickly as an assessment as well. And then once you have these two things together, you really, in order for you to be able to even integrate something with CI/CD pipeline, you need to test your hypothesis. So you can productionalize it, as in you can ensure that outputs are generated with LLM as an eval within 15 days or less. As long as you have the data, you should be able to do that. And then CI/CD can come through at a later point of time. Does that help answer your question?
Yes, absolutely. Thank you so much.
Anything?
All right, folks.
Sorry.
We're a little bit over time, so I want to be respectful of everyone's time. This was amazing, Alekhya. I think this was the first kind of meetup that we had that talked about specifically Evals in depth. So thank you so much. I think there is more interest in kind of like learning more about the pipelines and maybe even seeing the demos. Like I would personally love to see that if you ever want to do that. That'd be great because this is such a new area for a lot of us.
Absolutely.
Yeah, thank you everyone for joining. We will publish the recording. we have Mitra here, so as soon as Mitra processes it, maybe in the next week or so. And so again, to remind you guys, there's a LinkedIn channel and the YouTube channel that you can copy and subscribe to so you don't miss the recordings. You can ping me for the WhatsApp group link. And I also shared the promo code for the InnovateQA conference that is going to happen on June 4-5. So copy that so you don't lose it. Feel free to connect with me or Alekhya or anyone else on the call on LinkedIn. And we will see you guys next time. Thank you, Alekhya.
Thank you all.
Thank you.
Bye, all.
Thank you.